Hi, everybody. Welcome back. Let us look at problems on complex numbers, uh, and let us try to solve those kind of problems uh, as of now. Okay. So now, if I have a function uh, which is as an equation, that is equation which is z bar plus a z bar a z bar plus a bar z, okay, plus b is equal to 0. Okay, where b belongs to R, where b belongs to R. Okay, let us try to solve this problem here. Now, this represents a circle. Okay, this represents a circle. We have the following options. Okay, if a, the choice is mod a square. Okay, a is equal to b. I have another option here, which is b, which is mod a square is equal to or greater than b. Consider that. And c, I have c here, which is mod a square less than b. And I have another choice, which is none of these. So let us try to solve this problem here. Okay. Now, if I add and subtract a bar, if I add and subtract on both sides, uh, okay, if I add and subtract, so I get a z bar and a bar z plus b is equal to a bar. I'm adding and subtracting, okay, on both sides. I'm adding and subtracting on both sides. Okay, I get this. Now, if I form this, I get uh, this as z plus a into z bar plus a bar. Correct? If I try to simplify this, which is equal to you have plus b term. If I take it to the right hand side, so I get a a bar minus b. Okay, and now this I can write as z plus a and whole bar of this, and this I can write as mod of a uh, square minus b. Again, this whole thing I can write z plus a whole square mod a whole square. Now this represents a circle. Okay, this represents a circle which is centered at minus a, which is centered at minus a. Provided provided you have a mod of a square minus b should be greater than 0. So I can write this as mod a square which is greater than b. So hence we got into this solution for this. So the solution is this here. Okay, I hope you understood this problem. Let me move on to the next problem. Okay, if I have c plus I divides by c minus I, which is equal to a plus ib, which is equal to a plus ib. Okay, where you have a, b, c, which are real. Then what is a square plus b square? Then what is a square plus b square here? Okay, uh, the choices here are a, which is 7, now b, which is 1, c, which is c square, okay, and d, which is minus c square. Okay, we have choices like this. Now let us take this c plus I and c minus I. Multiply and divide by the conjugate of this, so it is c plus I and c plus I, which is equal to a plus ib. Now if I try to simplify further, so I get this as c square minus 1, okay, plus 2ic, which is equal to a plus ib into uh, c square plus 1. Now let us find what is a. A would be c square minus 1 and c square plus 1 divides by this, and b would be 2c divided by c square plus 1. Now let us square this and add. So a square plus b square, so that would be, if I try to simplify this further, I get c power 4 minus 2c square plus 1 plus 4c square divided by uh, here in the denominator I'll have again c square plus 1 whole square. Now if you look at this, so this is same. So when you cancel this out, you'll get 1. So the choice is 1. I hope you understood this problem here. If you have any queries, you can ask. Okay, I hope you understood this. Let me move on to the next problem here. Let me try to solve next problem. Now suppose if I have 3 plus 2i sine theta divided by 1 minus 2i sine theta will be real. This will be real if theta is, the choices are 2n pi, b n pi plus pi by 2, c which is n pi, and d which is none of these. Let us try to solve this here. The solution for this. Let us consider this given 2i sine theta divided by 1 minus 2i sine theta. Now multiply and divide by 1 plus 2i sine theta. Okay, 1 plus 2i sine theta. Multiply and divide by 1 plus 2i sine theta. So when I multiply this, I get 3 minus 4 sine square theta divided by 1 plus 4 sine square theta plus I 8 sine theta divided by 1 plus 4 sine square theta. Now, since this is real, so I can equate 8 sine theta by 1 plus 4 sine square theta equal to 0. You can consider that. So this implies sine theta is 0. So theta will be n pi for n is equal to 0, 1, 2 and so on. So the choice is this. So theta will be n pi. Okay, let us move on to the next problem here. Now, if I have 2 mod z minus 1 is equal to mod z minus 2 if x square plus y square is lambda x. Then lambda is equal to, I have choices here as 1 by 3, 2 by 3, 4 by 3, none. Let us try to understand this problem. If I have that, that is 2 times that of z minus 1 is equal to z mod of z minus 2. If x square plus y square is equal to lambda square, then you have to find what is lambda here. Now, if I square this on both sides of the equation, now z is x plus iy. So if I square this on both sides, so I get 4, okay, times that of x minus y, x minus 1, x minus 1 whole square plus y square, okay, which is equal to x minus 2 whole square plus y square. Okay, now this is x square plus y square, which is equal to 4x. Now, what we need is x square plus y square, which is 4 by 3 x. So lambda is 4 by 3 here. So this is a solution for that. I hope you understood this. Okay, let us move on to the next problem here. I'll be doing much more problems here. So those who are interested can join this. The live classes will be going on, and there will be also live interactions also. I've been getting mail from few students who are saying that to solve these kind of problems. So that's what I'm trying to do it. So let us waste no time. Let us look into next problem here. The point of intersection of the curve arc of z minus 3i is equal to 3 pi by 4. Okay, and the arc of 2z plus 1 minus 2i is equal to pi by 4, is equal to pi by 4. Okay, is the what is the point of intersection here? Let us see that. The choices are given as 1 by 4 of that of 3 plus 9. Okay, I have another choice which is 1 by 4 that of 9 plus 3i. Have another choice which is 1 plus I and none. The choices are these. Let us find the point of intersection for this arc of this. Okay. Now we have been given the arc of this. So let us consider that here. Now if you notice that here, so x is less than 0 and y minus 3, okay, y minus 3 is greater than 0. So we have y minus 3 divided by x is equal to tan 3 pi by 4, which is equal to minus 1. Okay, let us look at the real axis here. Okay, let me draw it. So this is the line. Okay, so this is somewhere here, which is minus 1 by 2 here, and this will be 2 here. Okay, so on the x axis, and I have another point which goes like this. Okay, this is 1 here somewhere. Okay, uh, if I take further, it's 1 somewhere here. So this is 0 comma 3. Okay, so this is the point which we get. So here x plus y minus 3 is equal to 0, where x is less than 0 and y is greater than 0. Uh, Consider this as 1. Now this arc of 2z plus 1, okay, first I have considered this. Let us consider this. Okay, minus 2i is equal to arc of. Now let us separate that. So real part 2x plus 1 plus I into 2y minus 2. I hope you understood this, what I've done here. Okay. So I've been getting queries. Few people haven't got this idea from where it came. So let me put this as r here as x plus you have y minus 3 into I. Okay, that's what I've done. E is equated to 3 pi by 4. That's what I've done. I hope you understood this. Yeah. Now this is pi by 4. Okay. From the first relation, I got these two, x as less than 0 and y as greater than 0. Okay. Now here x is greater than minus half. Okay. And y is greater than 1. And we have 2 times y minus 1 divided by 2x plus 1, which is equal to tan pi by 4, which is equal to 1. That's what I've mentioned here. So if you consider this equated to 1, so I get equation like 2x minus 2y, okay, 2x minus 2y plus 3 is equal to 0 for x greater than minus half and y greater than 1. So if you consider these two, so they don't have any point of intersection over here, as well as the diagram which I have showed here, the point of intersection is nowhere here. There is no intersection point here. So I hope you understood this. Okay, let us move on to the next problem here. This is quite interesting problem. Also, previous problems also were important for us. Now, if I have 1, alpha 1, alpha 2, alpha 3, and, and alpha 3n, okay, are the roots of the equation which is x to the power of 3n plus 1, are the roots of the equation 3n plus 1 minus 1 is equal to 0. And we have omega square, okay, are the imaginary cube roots of the unity. Then omega square minus alpha 1, omega square minus alpha 2, omega square minus alpha 3, and omega square minus uh, alpha 3n divides by omega alpha 1, omega alpha 2, omega alpha 3, and omega alpha n is equal to, what will be the solution for this? Let us uh, find that. The choices are omega, minus omega, 1, omega square. Okay, so these are the choices which are given to you. Let us try to find the solution for this here. Since we have uh, 1, alpha 1, alpha 2, and alpha 3n, okay, these are the roots, these are the roots here of the equation which is x to the power of 3n plus 1 minus 1. Okay, so that is equal to 0. Okay, now we can write that as x to the power of 3 minus 1 minus 1 is equal to x minus 1 into x minus alpha 1, x minus alpha 2, okay, and this is x minus alpha 3n. Okay, I can write this here. Now if I take to the other side, so I get x minus alpha 1, x minus alpha 2, x minus alpha 3, and x minus alpha 3n, which is equated to x to the power of 3n plus 1 minus 1 divided by x minus 1. Okay, now this is equated to 1 plus x square plus x to the power of 3n. Now if I consider e here, which is uh, omega square minus alpha 1, omega square alpha 2, omega square alpha 3n divides by omega alpha 1, omega alpha 2, omega alpha 3n. Now this is omega 6n plus 2 minus 1 divided by omega square minus 1. So multiplied with omega minus 1 and omega 3n plus 1 minus 1. Further, if I continue to solve this, so that is equal to omega square minus 1 into omega minus 1 divided by omega square minus 1 into omega minus 1. So if I cancel this out, I get this as 1. The solution for that is 1 here. So I hope you understood this. Uh, Thank you for listening, and let us see a few more problems after this session. Okay?